Welcome back, everybody. This is our Algebra 2 video on Algebra Essentials, Lesson 6 using tables on the calculator, homework review. And we are going to pick up from what we did for our store function using the graphing calculator. We're going to try to solve for this equation here. It's two of the following values of x are solutions to the equation x squared plus 4x minus 12 equal to 10x plus 4. Determine which they are and provide justification for each answer. So we're going to use our store function on the calculator. So let me just clear this and then clear this. Sorry about that, ladies and gentlemen. And go back to our home screen and clear all this stuff here. And so we're going to type in the first value, I believe was -2. Okay, good. So here we type in -2, store into x, hit enter. All right, so now let's type in x squared plus 4x minus 12. If we hit enter, we'll be able to plug in -2 for x, and we'll get a value of -16. Now we'll check out 10x plus 4. 10x plus 4. And we see here, -16, so -2 is one of our answers. Well, the next one we're going to try is, believe, -5. Okay, so let's go -5 here. So now I'm going to restore in this case. -5, store, x, and enter. Now, instead of typing out everything over again, we can bring the cursor up to the expression we want to. In this case, x squared plus 4x plus 12. Hit enter. And it will now just copy it back onto the calculator here, and enter again gives -7. We can do the same thing for 10x plus 4, saving us a little bit of time. Enter again. Not going to work out for -5. So we know -2 works out. All right, so our next number we'll try is, I believe, 6. All right, so let's try 6. So 6, store x. We hit enter. And we're going to move the cursor up to x squared plus 4x minus 12. Oops, went too far. There you go. Enter, and enter again. 48. Now, let's try in this case. Moving the cursor up to 10x plus 4. Hit enter. One more time, 64. So not this one. So the last one should be it, and that was 8. So we're going to store 8 for x. 8 store x. Now to check in this case, we'll have x squared plus 4x minus 12. Enter, 84. And let's plug into 10x plus 4, which I think should be the same thing. It is. Okay, so great. So we find now that the two values that work out are going to be -2 and 8. Okay, so we see that works out fine. Now, there's another way to do this too, because this is kind of inefficient, I think. It does work out, but to plug it over and over again, it's just a little bit much. So instead, let us go to y equals. And we're going to type out, in this case, the expression x squared plus 4x minus 12. And then, under y2, the other expression, 10x plus 4. Plus 4. Okay, now we could graph this, but instead what we're going to do is we're going to go to our table. Second table. And so now we have a ton of these, and we're looking for when the values for y2 and y1 are the same. Notice that we have 84. So both the left for y1, y2, and that's for 8. But there's another one, so maybe there's another way to do this. So we have 4 choices. Let's now go to the following, table set. And so we go to table set, we can set up how we want our table to come out. And so right now, we'll start at x equals 0, and do one space of 1 every single time. That triangle is delta table, meaning how we change the table. And both independent and dependent. Independent is the number we plug in, and the dependent is the output. So we're going to change this now from the independent from auto to ask. Okay, and so now we'll go to second table. Now it's clear. Now let's look at the choices. So first choice was -2. And so for x is equal to -2, we're looking to see whether or not they both have the same exact value. Here, -16, so if they both are equal to each other, a -2 is going to be a solution for the equation. The second one was, I believe, -5, right? Yes, -5. So we'll type in -5, enter, and so that doesn't work out. We'll type in 6, enter. The y1 and y2 not the same value, so that's not a solution. But 8, we know from before, typed in, gives us both 84. So our solutions are -2 and 8. So we can use our table in this manner, writing out each expression and then plugging in our values to see when they're both equal to each other. So especially with no some choice to work with, this might be a more efficient way of doing things. Up to you. Now we want to turn back our table setting. We'll hit second window or table sets, and we're going to change the table set back to auto for independent. This means in this case, though, the calculator will automatically fill in the values for us from, I guess, in units of 1, starting from 0. Okay, so that was our question number 3. Now for number 4. The quadratic expression x squared minus 8x plus 10 has the smallest value for some integer of x on the interval from 0 to 10. Set up a table to find the smallest value of the expression and the value of x that gives its value. Show your table below. Okay, so let us now fill it in our calculator. X squared, so now let's go to y is equal to. We're going to clear both of these. And I believe it said x squared. Now was it minus 8x? Let's double check. Yes, minus 8x plus 10. So minus 8x plus 10. All right. And so now, starting from, I believe it said from this was 0 to 10. So our 0 to 10, we're going to go to our table, second table, and notice all the values are written for us. Okay? So here from 0 to 10, we have 10, 3, -2, -5, -6, -5, -2, 3, 10, 19, and 30. So in this case, we see the smallest value is going to be at x equals 4. The smallest value is -6. So we can fill in our table here. So 10, 3, -2. Oops. Okay, so 10, 3, -2. 10, 3, -2. -5. -6, -5, -2, 3, 10, oops, that should be 8 here. This will be 10. When x equals 8, the expression equals 10. When x equals 9, the expression is 19. And for the last one, I'll have to scroll down just a little bit, and we gotta get 30. There you go. So this is our table, and so the value that gives the value that gives the lowest value for the expression is going to be when here x is equal to 4, and the matching value for expression, we'll call it the y value, is equal to -6. This is going to be our results, okay? And so I can put this in the full page, you guys can see. For the entire page. Okay? All right, nice. Okay, ladies and gentlemen, let's move on to our next question. Okay. So, we have here, consider the complex expression 7x plus 7 times x plus 3 plus x minus 1 times x minus 4. Multiply the two sets of binomials, combine like terms in order to write the expression in equivalent trinomial in standard form. Show your work. So we're going to multiply the x plus 7 times the x plus 3 first. And we're going to get x squared plus 3x plus 7x plus 21, or x squared plus 10x plus 21. Then we're going to multiply x minus 1, x minus 4, and we get x squared minus 4x minus 1x plus 4, or x squared minus 5x plus 4. And to combine these together, we're going to get 2x squared. Now 10x plus negative 5x is positive 5x, because 10 plus negative 5 is 5, and 21 plus 4 is plus 25. So this is going to be our expression. At this point, practice from last lesson, we should be able to multiply and add 4. Now set up your table to verify the answer. Part A is equivalent to expression. So what we're going to do, now here's the thing. Now how we're going to do this, I'm going to use our table. Okay, and so now go to y equals, I'm going to clear this. All right, and so we'll type in 2x squared, all right, plus 5x plus 25. And then for y2, we're going to write out the expression we had before. All right, so our expression, I believe, was parenthesis, was it x plus 7 times x plus 3? So parenthesis x plus 7 plus 7, close parenthesis, open parenthesis, x plus 3, close parenthesis, adding to that, I believe it was x minus 1, just to make sure x minus 1 to x minus 4, yeah. X minus 1, never hurts to be careful, let me check. X minus 1 times x minus 4. Okay, so now, having these both written out, all right, we're going to take a look at the x values and see the results. If, oops, there's an error I just noticed for the one before, as 2 pluses, there's going to be a syntax error here. So they say you can't have 2 pluses, so I'm going to delete one of them. Okay, so I was trying to say before, we use a table, and if both the y1 and y2 have the same exact matching values, then they are equivalent. So let's take a look. Second table. And it looks good. Both are giving us the same exact value. And now you can move this table and notice that even as I go into more negatives, they work out to be the same exact value. If I go working downwards here, they are exactly the same result, meaning that both expressions are equal, and when plugging the x values to both expressions, you'll get the same exact answer. So they are equivalent that way. So we can always check if you had a problem in just unsure of your work, in this case as far as multiplying, combining polynomials, you can, if you want to, just make sure, type the 1 into y1 and the original into y2 and check against the table to see whether or not you get the same exact result. Okay? All right, let's see, is there part C? Nope, no part C here. So we show our table, like I showed a table before on screen, and so we see they do work out. Now, if they did not work out, that means there was an error in computation. So be very careful, ladies and gentlemen. All right, so that's how this is the part 2, and we see here, not only do we store, we use our table. How we not only just use a table, compare expressions, we also use them to solve equations, and then also we saw how we can make adjustments to our table using table set. Okay, we'll probably do that in our next lesson, part 3, coming up on our last questions here. So ladies and gentlemen, thank you so much for watching. Please leave any questions or comments and feedback into the comment section below. Please leave a like for the video if you found it helpful, and please subscribe to the channel, turn on notifications. Thanks so much for watching. I'll see you in the next video, part 3. Take care.